Hi, today's a big day. I'm going to start the next big milestone in my engine here, and that is I'm going to start with animated meshes. So I can have 3D meshes that move and animate just like you and I. I don't know how far I'm going to get. It's going to be a big endeavor. I've never fully done this before, so we're going to just see how it goes. Just like everything else I've done so far, I'm going to make it slow. I'm going to make it stupid just to get results on the screen and then go back and optimize those as I need. So if I go back to my game here, yeah, right here, so I have this textured mesh. I don't know if it works. Yeah, so I got this character mesh here that's, oh, I just realized my mouse is backwards. Hold on, let me fix that real quick because I had to invert it for the thing, so that should be negative. There we go. Yeah, so he's way too big for the block that he's supposed to be representing, but it doesn't matter. Anyway, so I'm gonna try to work on some kind of system that allows me to animate it. So like when he jumps, he can maybe look like he's jumping or something. So we'll see how far I get with that. I don't know how far that will go, but we'll see. Wait, also, I just realized I had another kind of small bug. When I go into debug mode, it doesn't say debug mode is true. Let me fix that. I think that's because, yeah, I'm still using states debug mode. Basically just want to check if the states mode is equal to game mode debug. Okay, there we go. Now it's working. So that I could get rid of that debug mode boolean. Where else is that being used? Nowhere. Good. Okay. So that's good. So now that I'm doing that, I can start thinking about what I need to make animated meshes. I can get rid of that, by the way. So I got textured meshes here, which has all this stuff. And by the way, I don't think I need any of this stuff because I provide it when I tell the buffer to render it anyway. So if I delete that, 458, I don't think I need to do that anywhere. Okay, yeah, I'm not even initializing the orientation anyway. Yeah, everything still works. Okay, cool. Yeah, so now let's go back here and try to figure out what I need as part of my animated mesh. So let me see here if I have struct animated. I'm gonna call it animated mesh, and just it's gonna just be assumed that if you're animating your mesh, it better have texture coordinates with it. And if I want to animate something without texture coordinates, I can worry about that later. But for now, everything's gonna be textured. So this animated mesh is gonna have a textured mesh as part of it. And again, I don't know if this is all gonna stay. This is all just my first draft, whatever's in my brain. I'm just putting it on the screen. See if I can get something. So when I have an animated mesh, I need a mesh which has all of this. And then I need some kind of animation. So I need to make like a struct that represents what an animation is. I'm gonna call this mesh animation, just in case I ever do like 2D animations or something. And so a mesh animation is really just a bunch of poses and then some information to tell me how to interpolate between the poses. Keyframes, if you will. So I also need some kind of bone, some kind of representation as to what a pose is made up of. So a bone, I think it's really, I can do like a quaternion. So I need to know an orientation, like what rotation the bone is at. I need to know the position. And you could do scaling too, but for now I'm not going to scale any of my bones, as weird as that sounds. Everything's going to be, because you can't change the size of your bones in real life. So unless I have like a weird tentacle monster or something, for now you're not going to be able to change the size of the bones. So then you also need to know, so we have a bone. It's like part of a chain. So if, like, for example, when I move my upper arm, my bones that are connected to that also move that same way. So I have to know what the parent bone is. So let's say like parent, it's all going to be like in an array. So this is like a parent index, I guess. Okay, so that's a bone. So an animation is a array of bones, basically. And this is like the poses. So each pose, and then you need to know how many bones make up a skeleton. You need to know how many poses there are in the animation. So this would basically be this times this, the total of poses, I guess, or total bones in the whole animation is the total bones in the skeleton by the total poses. And then let's see what else. So I probably need to know like how many keyframes there are in a animation, and then probably like need to know like what the current keyframe I'm on is. And again, I don't know, I'm just putting all the stuff I think I need tentatively, and I can go back and change it all if needed. But so I need the total keyframes, whatever the current keyframe I'm on is. Oh, probably like a frame rate. Let me put this above here, because you can have the same animation but then just run it at different speeds. Okay, so all right, I think that's all I need for now, at least, you know, all I can think of for now. So then I'm going to say that the animated mesh has a mesh animation, and then you could, it's just going to be a pointer, so you can just change it, just have it point to a different animation if you want to change the animation, something like that. Yeah, I don't know. I really don't know, but we'll see. So I don't know where to go from here. You know, I should probably make a test animation just to see if it will, just to kind of gauge what kind of stuff I need to get out of this. So let's see, what can I do? I'm gonna make like a, I don't know, like a tentacle kind of thing. So I'm gonna make a cylinder. Let me put this up here. Okay, so then I want to put some bisections here. And since I'm in edit mode, let me go ahead and put the texture coordinates on it. All right, so now, so that's going to be my mesh, and then I'm going to add a skeleton to animate it. So let's see, how do I do? Add an armature, and I can't see it. I think if I go here, there we go. Now I can see it. All right, so let's extrude Z1, extrude Z1, Z1. Okay, I wanted this mesh smaller, actually. I wanted it 4 bones high, I guess. Okay, there we go. Well, you know what? Let me just go ahead and change the bone sizes. Okay, so let's put that back. Put that all the way. It doesn't have to be perfect. This is all just testing. Gravity. All right, that's good enough. All right, so I gotta remember how to make this thing animate. So I want to, I think, select this first and then the mesh, or the mesh and then that. There we go. Okay, so with automatic weights, and then I think that's all it takes. If I go to pose mode, okay, yeah, so that's working. But then I want to do some other things too, because so if I do that, so I want to go to weight paint mode, and I want to make sure that every weight is normalized, right? Because basically the vertices are going to be affected by one of these bones' orientation and position, and one vertex can be affected by multiple bones, and however many bones, I want the total weight that affects them all to add up to 1. So that's what I did there. And then the other thing I want to do is limit the total. I want to make sure that only none were affected. Yeah, I want to make sure that only a vertex could only be affected by a maximum of 4 bones. And that's just for optimization purposes, I guess. Okay, so I don't think that really affected anything, but it's just good to do, at least in this case. All right, so now I can actually start to make an animation. So I need my timeline thing here, and so I'm gonna start this at 0. So that's gonna be the like root pose, like the T pose, I suppose. And then so this current animation is just gonna be, I don't know, it's gonna be 24 frames long. It's gonna be just 1 second long. Actually, I'm gonna start this at 0. All right, so this first pose here, I wanna press T. So I wanna basically bake this pose into here as like the root pose. And then, so now the frame 1 is where I'll actually start the animation. So I'm gonna have it start, actually I'm gonna just have it start in the same spot. And then I'm gonna have it end in the same spot too. So then in the middle, or anywhere in here, I could just add keyframes and then it will figure out the rest. Right, so basically there I got my little tentacle waving hello at you. Okay, so now that I have a simple demo animation, I'm going to go into the scripting mode and just try to see if I can pick apart what kind of stuff I need to export from this. All right, so let me go back here, and so I know I need the object bpy.data.objects. Tab. So this time I want the cylinder. All right. So I already know how to get the vertices, the normals, the texture data. So all I really need, as far as the mesh is concerned, to render the mesh, I just need to know the bones that each vertex is affected by, and I need to know how much each vertex is affected by that bone, so the weights. So to get that, let's see, let me take a look at here. I think if they were smart, if they were doing it like how I would do it, they would put it as part of the vertices. That's an array. Okay, so that CO is the coordinate, and normal's the normal. So what can I say? What's groups? I think that sounds familiar because I think that's part of, because this is the actual mesh, and then the vertex groups is like all the, yeah, so this has all the bone data in there. So I think groups is what I want. So let me see. Groups dot, that's also an array. Oh, I see weight, that looks promising. That looks like what I want. There's only one group in that vertex. So what about vertex 1? It's like close to 1. All right, so I think that's what I want, the weight, and then the, what was the other one? So that's how much each vertex is affected by a bone, and then the, is it group maybe? It's probably that one. That's gonna say which bone is affecting that. I don't know, let me just try to get this stuff here. So let me see, object is bpy dot data dot objects cylinder, and then verts is object Okay, I'm just gonna go ahead and start iterating through these. So for I v in enumerate verts. So so the verts has a position. Norm is v dot norm. Oh, but I also need the polygons too. I forgot all about that. Polygons. Yeah, okay. So data dot object dot data dot polygons. That's what I meant to say. If I can ever type it. Okay, so there's the polygon. So before I can iterate through the vertices, I got to iterate through the polygons. So for I p polys. So as I'm doing that, okay, yeah, so then I need to iterate through the polygons vertices. That's 4j in, I think I just, p dot. Hold on. Yeah, okay. Just making sure it's an array. So for v in p dot vertices, so now position is verts at v dot co. And the normal is verts at v dot normal. Okay, so then here is the so it's gonna be different then. I gotta do like this, I think. I gotta say okay, so there's only a maximum of 4 weights, but that's a maximum. So there's a minimum of 0. Like a bone cannot be, or a vertex cannot be affected by any bones if it doesn't need to be. So in that case, I want all the weights to be 0, and then it doesn't matter what bone it is affected by at that point, because it's just going to end up being the same position it was anyway. So I'm going to say bones is also the same thing. But then now I need to iterate through, because the groups, because there's multiple groups per vertex, right? So I think I need to do a new array. So for G in verts at v dot groups. Right, that sounds right. And then, so then with that G, I can get the weight and the group, right? Let me just try to bring that up. G dot weight print G dot group. All right, does that even compile? It did, it compiled, I'm surprised. All right, this actually looks like some promising output here. So that is a weight to that bone. Weights. They don't look very normalized though. They're all pointing to the same bone. Oh, here we go. 0.92, 0.01, but that's still, I don't know, I'm really not sure what I'm looking at. Let me try to normalize them again. Maybe I needed to do that after I limited the weights. Normalize, oh, maybe I need to. There we go. Okay, so now let's see. I need to clear the screen too. So from OS import system hide it. Yeah, actually, I don't know. I have really no idea to tell if that's accurate or not. But I mean, the numbers look right. I mean, I'm getting a decimal value for there and an integer value for there, so that seems accurate. But seeming and being are two different things. So we'll just have to see. So I think, okay, so I think I'm going to dig out the other textured mesh outputter thing. Texture mesh exporter. I don't want to do the full plugin yet. I just want to take the meat of the code here. All right, so I'm gonna have to hard code some stuff. I forgot about those. Okay, so this is going to be cylinder for this test. And let's see. So then the output file location is going to change. It's going to be C:/ user/ me/desktop/ tentacle test dot, I'll call it animesh. So I needed the file name, the file location. What else did I have to provide? Oh, the file name, which is part of that. So I think it should run. Nope. That's because of that. Math utils. I need to import math utils. Is that right? I don't remember how to import math utils. From, oh, it is just math utils, okay. Math is not defined. Probably need to import that too, right? Yep. More. Array is not defined. Should have just copied it all. There we go. All right, so nothing printed out, but I do have that, which doesn't really help me. Okay, so that was just to make sure that it would work. So now I just got to pack in the weights and all that stuff. So I guess I could do that here. Pretty much just put what I had before. So I'll say weights is an array of zeros. And same for, not groups, I'll call it bones. And then now we need to iterate through for b in ferts at v dot groups. And then I should probably just do a double check to make sure that I'm not going to go more than 4 bones. So I'm going to say if, actually, no, I need to enumerate now. So if that in enumerate groups. So if k is greater than 3, I need to break out of this loop. Something's wrong. But otherwise, we want to then say weights at k is equal to b dot weight. And then bones at k is equal to b dot group. All right, just don't want to do a verification print, but of course it's not working. Oh, it's bones. What? Okay. Yeah, that's a lot better. So these definitely look normalized, and yeah, okay, so that looks good. So now I want to tack on these to the vertex. Can you append multiple things? What happened? 0. Oh, I had this backwards. There we go. Okay, so I don't know. Okay, so now when I do that, I should have all of that extra stuff packed in here. I don't know if I do or not. So let me go back to my game code here and create a function for creating a animated texture or animated mesh. Okay, so I'll put it right below this one here. All right, it's pretty much taking all the same stuff as the other one above it. In fact, I can just copy it. And so I can make an animated mesh. Is this not right? And make mesh. Okay, just making sure. That's what I eventually want to return, and then let's see. Well, I know I can say that the mesh is mesh. Right, it does have a mesh. Yeah. So that could just be equal to the function above it. Create textured mesh, passing in the file. No, I want to pass in the data. Text data size. And then, yeah, everything else. Okay. Oh, that's why it was wigging out. There we go. All right, so okay, so this is gonna have. Well, this is okay. So this is wrong because this is gonna have the. This is gonna have way too much vertex data, so I can't actually just use this function here. I'm trying to repurpose. I mean, I could make a whole nother renderer, but I'm trying to repurpose my texture, my 2D, my whatever, my textured mesh renderer, which I don't know if that's the best thing to do. I don't know how to do this. Let me just try to figure out, let me try to see if I can parse out just the mesh data and see if I can get that rendering. That would be fun. Okay, so this isn't the data I want to send. I need to parse out the data that I need. So the vertex data size is, so for each vertex, let's say it's just one vertex, then I got 3 floats for the position, 3 for the normal, 2 for the texture, 4 for the weight, 4 for the the bone. So that's 8, 10, 16. 16 floats. 16 times 4 is 64. So each vertex is 64 bytes. Or wait, so if I take the vertex data size, divide it by 64, that'll be the total vertices. So U32 total vertices is the vertex data size divided by 64, which, wait a minute, divided by 2, 4, 8, 16, 32. Can I just shift it to the right 6? Is that the same thing? No, I have to test. Okay, so A and B are the same thing. I'm going to say that works. Okay, so that okay, so that's the total vertices, and then oh, it's all interwoven though, isn't it? Oh well. All right, so let me make a float 32 v pointer equal to the float 32 pointer of the temp storage buffer. So I'm just going to put all the vertex position, normal, and texture data onto the temp storage buffer, and then use that for now to create the mesh. This is all dumb. I don't know why I'm doing this. Yeah, so for U32 I0 I is less than total vertices I plus plus. So as I iterate through the vertices, I want to collect the position, the normal, and the texture UV coordinates. So that's V pointer I think I can do this. So V pointer plus plus is equal to okay, so I have another pointer too. Okay, so that's just going to point to the vertex data, and so now we're going to have V pointer, actually whatever V pointer is pointing at is going to equal D pointer, whatever D pointer is pointing at. Yeah, so we're gonna have to do that 3 times. Nah, it's gonna be too much. Okay, so let's just do it like this here. So for U32 J. Okay, so that's going to get the positions, that's going to do the normals, and that's going to do the UV chords. then after each iteration, I want the data pointer to increase 8 floats, because 4 for the weights, 4 for the bones, and then so instead of vertex data, we want to send in the vertex pointer. And then the vertex data size is actually now total vertices times, so that's 1, 2, 3, 4, 5, 6, 7, 8 floats, 8 times 4, which is 32, right? Yeah, so, yeah, okay, so that makes sense, half of the size. Okay, I don't even know if that's going to compile, let's see. No. 466. Oh. There we go. Okay, so let me try to make a textured mesh with my tentacle. Probably want to drag that into the project. So we'll do that right here, right below where we initialize the game state. We're going to say that okay, so we're going to read file into the buffer. We're going to file is, what did I call it? Tentacle? Tentacle text. Why do I call it text? All right, so that's the file, and then the data it's going to go into is just the temp storage buffer, and then the file length is, I don't know, file length, whatever you decide to tell me it is. Yeah, everything else should just be the same, so I need F32 V size. No, it's U32. I size, and then now I need the F32 pointer, V data, and then the U16 pointer, which is I data. Okay, so that's going to be equal to all right, okay, so I need to cast this to a U32 pointer, and then that's going to be the TSB PTR. And the same for U. And then U slightly different. PTR. Okay, so that was a lot of work for, it's probably not going to pay off, but now that that's done, I can now try to create one of those animated textured meshes. What is this even for? Okay, good. That was just old code lingering around. So now I need to make a animated mesh. I'll call this tentacle and that's going to equal create animated mesh. Okay, so I'm going to pass in the vertex data, which is vData, and then vSize, and then iData, iSize. Okay, if that runs without causing any crazy errors, I'll be very surprised. Oh my goodness. All right. So now the test is, can I render that tentacle? If I can, that will be a feat. So I guess after I update the game state, I can try. Add textured mesh to buffer. I need to pass in the game state. The mesh is tentacle dot mesh. Just put it right there in the middle. Let's make it standard size and standard orientation. That's it. Textured mesh to textured mesh pointer. It's not a pointer. And 68. So it takes the game state, and then it takes a textured mesh pointer. Oh, it does take a, okay, so I needed to pass in the address of it. There we go. And we got something, but not what I'm looking for. All right, so let me see why that would be happening. Let's debug this. Okay, so vSize is that iSize. Oh yeah, that's the problem. vSize and iSize should not be the same thing. So we need to do TSB pointer plus equals 4 bytes, and then same there, and that should do it. Hey, still no difference. Okay, so vSize 18304, iSize is 2208. Yeah, that should definitely be bigger. All right, so vertex data size is 18304, and then I'm shifting it right 6, which should be the same as dividing it by 64, which gives me 286. Yes, correct. So then this is pointing at there. D pointer is pointing at the vertex data. So going through the total vertices. And then, so this is the positions for each one. All right, and then the normals. And the UV coordinates. And then you want to increase that 8, wait, DPTO is float, yeah, so 8 floats. So that it goes. All right, and then that's going to repeat a bunch. So I don't know. It all seems good, but of course you can never tell. So then the total vertices is that right there? Wait, so if it was one vertex, it would be, double check. All right, so 3 floats for the position, 3 floats for the normal, 2 floats for the texture, weight, the bones. So that's, wait a minute, I got that way wrong. 3 times 3 times 2. No, wait, hold on. 3 plus 3 plus 2 plus 4 plus 4. So 16 floats. Each float is 4 bytes. So 1 is 64. So if I take the total divided by 64, that should give me the total vertices. Yes, that's right. So the total vertices is that. And then if I get the pointer to the temp storage where the data is currently being held. No, that's not right. Vertex pointer. But nothing's going out of bounds though, so that's tells me something's at least kind of right. Like I'm not getting any weird like exceptions or anything. Really need to increase the camera's move speed. It's really slow. But yeah, that is just a big jumbled mess of polygons. Wait. No, never mind. I don't know. Drawing blanks here. I feel like vertices. That would be right though. Total vertices times 5 times 4. No, 5 times, yeah, 5 times 4. No, it's 8. It's 8 times 4. I'm dumb. Okay, so that's 8 times 4 is definitely 32, right? Yeah, okay. Okay, let me try stepping through this one more time, and if I can't figure it out, I'm gonna probably just wrap it up here. So I guess I couldn't look at what the frequency is. Yeah, I don't know. I'm not even really able to follow the logic. I mean, it seems like it's all right, but I don't know why my cylinder is looking like this. I mean, I know why it's pointed that way. It's the coordinate system's different between my game and Blender, but the fact that it's not looking like a cylinder is throwing me for a loop. I mean, it looks like the triangle, like the positions are probably okay. It's just the order that they're being rendered in is wrong. Well, maybe not. Take that back. So this should be. I don't know. I'm gonna take a break and then look at it next time with fresher eyes. So yeah, I'm gonna go ahead and save what I got. I don't know. It's not really anything to save, but whatever. Okay, so that's saving. While that's saving, I'm going to be signing out. So thank you, everybody. See you next time when we fix this animation system and at least make progress on it. Thank you. Bye.